Okay, so you may not be happy with this, but I added one more little assignment because I decided when I made that last video that you did not have enough problems where you're solving exponential equations by finding common bases. So I made another little lesson 7-2. There's just 5 problems. I'm going to do a couple, and this is the whole 5 problems are all the same. It's just solving equations, finding common bases. So I'm just going to go over a couple. I did one at the end of that last video on 7-2 on that other 7-2 lesson. So I'm going to do a couple here. Okay, so remember, we're trying to get these bases, these big numbers, the same. So what you want to do is break them down into think of perfect squares, things like that. So when I look at 8 and 16, I know 2 will go into them. 4 will go into them, but 4 will go into 16 2 times, but the problem is 4 won't go into 8 more than once. So 4 won't work, so we got to do 2. So if I go to 16, 2, and you know, go over and use a calculator if you want, but think about prime factorization. You would go 4 times 4, and then you would go 2 times 2 times 2 times 2 if you were doing it in your head. So there's 4 2s in 16. So 2 to the 4th. So then 8, if you did prime factorization, you got 4 times 2, and then that 4 will break into 2 and 2. So you got 3 2s on 8. So that's going to go 3, but then, oops, forgot my 2, sorry. Put an 8. Okay, so that changes a 2 to the 3rd. But on this side, what you have to remember is you already had an expression up there. So you have to distribute. Our new 3 that we made, we have to distribute. So that's going to end up being 3x minus 9. This one's 2 to the 4th. Now, once you have common bases, now you can set those exponents equal to each other. That's just a rule in algebra, okay? So now we can solve this. So we add 9. So that's 3x equals 13. And then divide by 3. And then you can just put that fraction in, 13 over 3, into your Alex. Okay, so there's one. You do one more, just to make sure you get it. Since I added this assignment, we get a little bit bigger numbers. Find something that might be, well, this one will have to do. Okay, so this one's 64 on one side, and then the other side is 32, and then negative x plus 3 in the exponent. Okay, so again, you got to think about, how could I break this number apart? And I keep going back to prime factorization. You know, you learned that way back in middle school, maybe even grade school. You learned it for a reason, because it's important to understand it. Even if you're going to use a calculator, it's important to understand, how could I break this number down? Think of something easy that goes into it. Well, I immediately see these two numbers, they're evens. I know 2 will go into them. We could do a bigger number. You could do 4, because 32, 4 would go into 32. 8? 8 times 4 is 32. And then into 64, that's 8 times 8. Let's do 64. And again, you can do this and you don't got to be doing this in your head like I am, but so I could do 8, but 8 you can't do over here because there's only one 8. So let's try 4s, because 2s are, a little bit too small. Maybe. There's 4 times 2. This is 4 times 2. But remember, it's got to go evenly. You've got to be able to say 4 to the 2nd power, 4 to the 3rd. Here, this is a problem, because you got two fours, but then you have this 2. What are you going to do with it? So we may have to just do 2s. 2, break your 4s down. So how many 2s are in 32? 1, 2, 3, 4, 5. So 32 breaks into, keep writing the same number back. You got to remember that once you determine what your new base is, that's what you got to write down. I keep writing the original number. Okay, so now my new base for 32 is 2 to the 5th. So I changed it to 2 to the 5th. 64, if I break these 4s down, it's going to have 1, 2, 3, 1, 2, 3, 6s. Or, sorry, 6 2s. So 6 2s are 64 and 5 2s are 32. Seem right? Okay. So now don't forget that you have this original expression that you have to distribute. So that's 2 to the 6th. And then that'll distribute. So 2, that'll be negative 5x plus 15. And so now you have bases of 2. So now you can set, once you have common bases, you can set your exponents. Think of like the bases cancel, and you set them equal to each other. And so now I can solve. So I subtract 15. And then 6 minus 15 is negative 9 equals negative 5x. And I divide by negative 5. So this will finish off by just canceling those negatives. So it'll be 9/5. Okay, so there's a couple of solving exponential equations by finding common bases. That's what we're doing here. So you have one more little lesson that you have to do, 7-2. There is 5 problems that are all like this. All right.